Neuralink, a neurotechnology company owned by billionaire Elon Musk, has now implanted its first brain chip in a human patient. This wireless chip was first tested in pigs and monkeys before being cleared for human trials by the FDA. The chip is said to be the future of technology and medicine and will have several applications, including restoring motor functionality in people who have been impaired in this way. So is this indeed the future of medicine? Let's unpack this story further. We're joined this morning by a neurologist from UCT's Neuroscience Institute, Associate Professor there, Sam Nightingale. It's great to talk to you. Thanks very much indeed for coming on to the program. Are you excited about this development? I know just from the research that we've been doing in preparing for this interview that this is not the first brain chip of its kind, but I do believe it's the first one to be implanted by the skull being opened. Is that right?
Well, that's right. So, I mean, I think I have some excitement about this. I mean, the use of this technology is very exciting in some limited ways. So you mentioned with paralysis, some people with amputations could benefit from this. And there's a particular syndrome called locked-in syndrome. I've had patients with this. It's a devastating condition where the brain's working perfectly well, the body's working perfectly well, but the signals, the small area of the brain stem where the signals from the brain get through to the body is damaged, usually by a stroke. And so this person would be completely paralyzed, including most of the muscles of the head and the face. And these kind of implements can be used to allow them to move a cursor on the screen and communicate in some way. So those kind of cases are relatively rare, but it's very exciting technology for those patients.
Yeah, absolutely. The one concerning thing for me is that, this issue of restoring motor functionality in people and perhaps even enabling a brain-computer interface. These are claims that have not been independently verified, right? We don't know whether it will indeed work.
Well, I think it will work in some way. It depends to what extent and what you mean by brain-computer interface. I mean, in its basic form, we already have some kind of brain-computer interface.
Right.
We can record the electrical signals from the brain. I mean, the brain, it's lots of tiny little nerve cells with tiny little electrical impulses, and we can actually record that with electrodes over the brain. We do that quite often at the hospital here at UCT, and they're very, very low amplitude and very low signals, but we can just about record them with electrodes just sitting on the scalp on the outside there. But there's a lot of noise, as you can imagine. There's noise from the muscles around underneath the skin. There's the bone that's in the way, etc. Every time even a hair moves, it causes a noise and an interference. So what they've done here is they've implanted them beneath the skull onto the brain, decreasing that amount of noise and getting a clearer signal.
Wow.
Now, if you connect that signal up to a computer, then I guess that's a brain-computer interface. But it's a bit of a long way from what the more sci-fi applications people think of, that a brain can read our thoughts or that even a brain can control our movements.
Yeah. It's fascinating. And listening to you explain the details of it, this device the size of a coin, surgically implanted in the skull, and then these ultra-thin wires going into the brain. And what Elon Musk had to say on Monday was actually that already they've seen some initial results showing some promising neuron spike detection. It is very, sort of, as you say, sci-fi movie-like, right?
Well, I think it is and it isn't. I mean, some of this stuff we already do to some extent. We have patients with certain type of epilepsy that we implant these kind of electrodes over the area where we think the epilepsy is coming from to record very carefully to see if we can find the exact spot the epilepsy is coming from and whether they might benefit from surgical removal of that area to improve their seizures. So some of these things already happen. I would be surprised if they weren't recording some kind of nerve impulses, if they put electrodes over the brain, considering that the brain consists of nerves which have impulses. So to some extent, I'm not necessarily surprised, and what they're doing really is going to have a very limited benefit. The amount of information the computer get will be relatively limited. I think the sci-fi parts come when you start scaling this up, when you imagine where this could go, to what extent it could go, to? Could it start really interacting with our brains in a more meaningful way, such that our brain power can be connected to the power of computers? And I think my impression is that's what people like Elon Musk are most interested here, not necessarily in helping people with paralysis or locked-in syndrome, but more, enhancing the ability of the human brain. Our human brains are incredibly complex and powerful, but they're quite slow and they're quite inaccurate. And so the computing power is much faster and much more accurate. So connecting those two sort of biological and silicon systems could be incredibly powerful. I think that's really where people like Elon Musk are hoping this technology goes. But I think we're probably quite a long way away from it yet.
Fascinating stuff. In terms of ethical concerns, and there have been many that have been raised, right? Privacy, surveillance. There's not been a lot of detail on the user's ability to retain control of neural activity, of personal data. What's some of your ethical concerns?
Look, I think this kind of thing, whenever there's a completely new technology that changes a paradigm, people have to wrap their heads around what the ethical concerns might be in a different way. I think we're a very, very long way away from the idea that a computer could read private thoughts. I mean, essentially it is thought. If it's collecting electrical signals from brainwaves and looking at those, essentially it's reading a thought. And actually people have used this kind of technology to read paralyzed people's intentions to speak and manage to decode what words they were trying to say. So in that sense, they are reading their thoughts. But what people really were worried about is the idea that they could sort of download their memories or read their more private thoughts. And I think we're a very, very long way away from that, because that's a completely different part of the brain with a completely different level of complexity. But of course, were the technology to get anywhere close to that, there would have to be a completely new set of legislation and ways that we manage the ethical concerns. I think in the shorter term, concerns are more around the safety of these things. I mean, it's not obviously brain surgery, it's not without its risks. We understand some of the animals that were involved, had complications such as brain bleeding and seizures and other things. And of course, those are possible in humans. Now, if it's being used to help somebody who has, for example, locked-in syndrome communicate with their relatives and carers, or somebody who's paralyzed, perhaps move a limb again, then those risks might be balanced. But if it's being used, as Elon has said a few times, to move, to help you connect more quickly with your phone, start thinking, are those risks really justifiable? Yeah,
because there is another company, an Australian-based company, Synchron, right? It's got a similar device that I'm sure you're aware of, and they implanted its device in a US patient in July of 2022, and that's a device that doesn't require cutting into the skull. And as you say, other trials of this nature are more focused on the medicine and the medical possibilities around technology like this, whereas Elon Musk obviously takes it a step further to the smartphone and device connection.
I think the medical applications are a proof of principle, really. The amount of money and interest in this, my impression is that it's not focused on helping the relatively small number of people with neurological illnesses, which is a shame. I think people are really focused on the larger applications of linking human brains to computers. But the medical applications are really, really important, and they're the kind of thing we would be interested in at the Neuroscience Institute at UCT. Using technology to try to improve the lives of people with these kind of devastating neurological problems. Yeah,
absolutely. And in your research, Prof, as we wrap up our conversation, you focus on cognitive impairment, specifically of HIV infection and HIV-infected patients. How specifically would you like to see this kind of technology influence the work and the research that you're doing?
Well, that's right. So I look at the effect of HIV on the brain, and in particular, my latest project actually is funded by the Donald Gordon Foundation and the Race Against Dementia, and we're looking at Alzheimer's disease in people with HIV, the risk of people with HIV getting Alzheimer's disease, to try to understand, firstly, what the risk we're getting people with HIV living into older age for the first time ever, which is due to the fabulous success of antiretrovirals. We want to understand how these people age, and also hopefully understand a bit more about Alzheimer's disease. And these kind of technologies could potentially help us understand the mechanisms, what's going on in the brain, and could conceivably help recovery and help with enhancing people's memories or recording people's memories in different ways. It's not something I'm looking at specifically, and as I said before, the technology is some way off something like that, but it's something that we could certainly keep an eye on.
Fascinating discussion. Prof, let me thank you for your time this morning. It's been great getting your insights into something that does feel otherworldly, right, to those of us who are not in the industry. Associate Professor Sam Nightingale, he's a neurologist with the UCT Neuroscience Institute, as we continue to look at some of the innovations insofar as Elon Musk's Neuralink brain chip is concerned.